So the next test is actually one that we've talked about before, back when we reviewed geometric series. But it is actually a test for convergence. If I have a geometric series, which would be in the form of a series where n is starting at some real number and going to infinity, of a times r to the n, where a would be part of my first term, r is my common ratio, and we know that converges to the first term over 1 minus r if r is between -1 and 1. So if you recognize that you have a geometric series, you can apply the geometric series test. I will be honest, once we go through all of these tests, this is an easy one to forget to try, just because you have to be looking and say, is this a geometric series for it to work? The key to this being a geometric series is that you have a constant raised to the n power. That serves as your common ratio. And then you only have a constant multiple outside of that term. So if we look at some examples here, if I have the series where n goes from 1 to infinity of 5 times -2/3 to the n, this is my r. So r is -2/3. And since -2/3 is between -1 and 1, this means that the series converges by the geometric series test. If I look here, n goes from 0 to infinity of e to the n. R is my e value. My a would just be a 1 here. Because r is equal to e, and e is bigger than 1, in other words, it's not between -1 and 1, this series diverges. And if I'm asked for the reason, it would be by the geometric series test. You don't really need to say the names of the tests that you're using. By showing your work, you are communicating what test you are doing. It's a lot like when we're working with our theorems, like the mean value theorem, intermediate value theorem, etc. You don't have to say the names of them as long as you're showing the work that goes into it. That idea of I'm checking my hypothesis in order to reach the conclusion. By showing that I'm saying, well, here's what R is, does it lie between -1 and 1, yes or no? That's me showing the hypothesis, which then leads to my conclusion of converge or diverge.